Hey, hi, good evening. Guys, tell me, I'm an audible, right? Just for the formalities. So just wait for further few minutes. Okay, 5:30 होने दे, बाद में क्लास स्टार्ट करते हैं. अब बताओ. Hey, hello, hi, good evening. Guys, please let me know, notify here in the chat box. I'm an audible, right? Am I audible? Yes, thank you. How was the day? How is your preparation are going on? Yes, well, let's start our today's session. Guys, if you're getting any doubt meanwhile while teaching the class, okay, please drop your doubts in the chat box. I will try my level best to give you answers. Okay. Yes. Well. Okay. Once again, welcome to all of you. This is Sham, working from Jenny Haveri. And today in this class, we're going to discuss about the last topic of the dual nature of matter and radiation. That is de Broglie hypothesis. Right now, actually, he's a person. He given a complete conclusion about the light, whether it is particle nature or wave nature. We have a confusion, no. But he clearly clarified that doubt, and he said that light has a dual characteristics, double rule. Okay, that is light acting as an particle also and as well as wave also. But based on the particle nature and the wave nature, few phenomena which we are observing in our daily life, like interference of light and means we know right optics में क्या क्या पढ़ाते हैं उधर हम treat करते हैं light as an wave and as well as straight line it is moving, but through the photoelectric effect component in particle nature. That's why he gave a beautiful equation. What is the wavelength which is associated with the matter and everything, which we are going to study under this class. And we are going to this experimental evidence. What he given? No, it is exactly proven by the Davison and Germer. Okay, these are the two scientists. They practically prove this one. Okay, we are going to discuss that one also, and later on few numericals which we are going to solve in this today class. This is all. This is all about today's class topics. Okay, let's get into the topic. Before getting into the topic, we'll take a quick recall what we discussed in our last class. Okay, last class हम discuss करे थे few equation which are associated with the Einstein photoelectric effect. Correct now? What are those? First thing we discussed, E is equal to, sorry, means energy is equal to work function plus kinetic energy. In different format we written. E को h nu and work function को h nu naught. Kinetic energy as an, just a minute. Yeah. Kinetic energy as an of mv square. Correct now? Again we take the h nu naught left hand side and we got one more equation. From this equation, we can clearly say that this kinetic energy is proportional to the frequency. If you increase the value of frequency, the value of kinetic energy also increases. Keep these points in mind. Okay, don't get idly, don't say anything. Okay, here you may observe the energy value will be equal to h nu minus h nu naught. Correct now? Here h is a constant and it is depending, this whole equation depending upon the frequency. Means energy is depending upon the frequency, kinetic energy. You can say that one also, there is no problem. This is a kinetic energy. Clear enough? Good. Next, in terms of lambda we written, and kinetic energy in terms of electron volt we written. Electron volt means a charge which is moving in one potential difference, how much it will be moved, that is called the work done. Correct now? This work done stored as in kinetic energy. That's why we written kinetic energy as an electron volt here, and we then replace this one also. Correct now? And here from this point we got to know that this electron volt is proportional to the kinetic energy potential also. And coming to the next point, again, if you're going to replace the kinetic energy by electron volt, here the voltage is directly proportional to the frequency again. Clear? And next point we talk about this different graphs. Correct. Now first is frequency versus stopping potential. If you're changing the frequency is changing nothing but changing energy. Changing frequency is nothing but changing the energy. Changing the energy is nothing but changing the color of light. Clear? Color of light. Energy, frequency, color same hai. And brightness is proportional to the intensity of light. Intensity is nothing but brightness. If you change the frequency of light, means stopping potential also increases gradually. We shown this one, and this slope will give the value of h by e. And if you want to draw the slope by negative interception in a y-axis, means it will give the work function per unit electron. It will give this value will be always negative, means almost all electron bound to the nucleus, that value will be given by this negative symbol. Next, coming to the frequency versus stopping potential. Here for different metal different work function होता है. Oh god, करंट गया. Okay, चलो मैं कैमरा ऑफ करता हूँ. Different metal को different work function होता है. Similarly, different metal को different threshold frequency होता है. That's why for first metal the threshold frequency value will start from this point. Means second, if it has a work function more than the metal A, means it will be start from this point. Correct? Correct now? Okay, cool. Then next what we discussed. Okay. Later on we discussed about the intensity and stopping potential. Actually, intensity and stopping potential non-related. By changing intensity, photocurrent increases. Photocurrent value will be increases, but stopping potential will be same because if you took one color means that is the energy means उसका frequency नहीं change होता है. When frequency change होता है, that time only the stopping potential will be changes. Correct ना? That's why by changing intensity of light, we can't change the stopping potential. That's why we got a straight line. Correct. And later on, time versus photoelectric current. Correct. It's an instantaneous process. We told spontaneous process. In a 10 to the power of minus 9 second only, the current will rapidly increases. Correct. Means rapidly this photoelectron will be start to eject. After then, current will become saturation. No, that is what we are showing in along the x-axis parallel. Cool. This is all about we discussed in the last class. If you have any doubt means please drop your doubt in the chat box quickly. Or else if you don't have any doubt means please let me know there is no doubt, sir. Like I'm waiting for your answer. Yes. Okay, let's start. But थोड़ा सा resistance है इधर. क्या है ना? I have a question. Okay, first answer the question which is asked here. The question says that the slope of the frequency of incident light and as well as the stopping potential for a given surface will be. What is the correct answer for this question? What will be the correct answer? No. What I told yesterday. No, only I explained, but you didn't notice this one. Correct now? For a given material, along the x-axis, frequency, along the y-axis, stopping potential if you're going to take means for a particular metal, the line will be go like this. Correct now? This slope value, if you're going to cut like this means it will give the value of h by e. Correct now? In a backward direction, if you extend means here it will be give the value of work function per unit electron. Right? Don't forget this one. Where we draw this one? Actually, देखो इधर h nu minus h nu naught is equal to kinetic energy. We can write as an electron volt. Correct ना? Volt चाहिए हमको means take e to left hand side, then it will become h by e minus h by e. Here nu है, nu naught है, voltage हो गया. Correct now? Here voltage is proportional to the nu and nu naught. The slope will give the value of h by e. Correct? Simple सा है. Okay, but you need to know about how to write the equations. Equations के ऊपर depend करता है इधर सब कुछ. Okay, ತೊಂದ್ರೆ ಇಲ್ಲ. Next ಇನ್ನೊಂದು question ಇದೆ. Try ಮಾಡಿ ಇದನ್ನ. Try ಮಾಡಿ. Threshold wavelength for a given metal of work function phi is lambda. Equation ಕೊಟ್ಟಿದ್ದಾರೆ. What is the threshold wavelength for a metal whose work function is pi by 2? Pi by 2 ಆಯ್ತು ಅಂದ್ರೆ threshold wavelength ಏನಾಯ್ತು ಅಂತ ಕೇಳ್ತಾರೆ. ನೋಡೋಣ. ಟ್ರೈ ಮಾಡಿ. ಸಿಂಪಲ್ ಸ ಕ್ವಶನ್, ಸ್ವಲ್ಪ ತಲೆ ಉಪಯೋಗಿಸ್ಬೇಕಷ್ಟೇ. ಹೇ ಶಬಾಷ್. क्या है? राइट, 2 लैम्डा. क्या कैसे? एक्चुअली वर्क फंक्शन तो पता है h mu naught. Okay, this is the original one. Okay, if I am going to change some other metal whose work function क्या है? Pi naught by 2 means इधर h nu को we can write as an c by lambda. इधर क्या था? h c by lambda था. Correct now? Now this value of lambda we need. It is directly proportional to 2 times no. That's why we can write it as an 2 times the lambda. Right. Correct. Okay, then we'll start our dual nature of light. From this point only we will get a complete idea from the de Broglie. Who is this person? De Broglie. अच्छा है ना? कन्नड़ा में कन्नड़ದಲ್ಲಿ ಒಂದು ಮೂವಿ ಬರ್ತಾ ಇದೆ ಚಾರ್ಲಿ, like that de Broglie. Right. Already I told you that electromagnetic waves and radiation. Okay, these are all like a wave theory. From this theory only we can completely know, we go through like interference, correct? Interference, and then diffraction, diffraction, correct now, and as well as uh, de Broglie का और एक experiment था, not de Broglie, Hertz experiment, Hertz. From this all the things we concluded that light is an wave, that is an electromagnetic wave, correct now. Coming to the next one, quantum theory. Here especially photoelectric effect, photoelectric effect. While explaining the photoelectric effect, I told you guys, according to the Einstein, हमारा आइंस्टीन है ना, कौन है हमारा आइंस्टीन, ओके। ये मेटल सरफेस के ऊपर एक इलेक्ट्रॉन है, मीन्स इसको एजेक्ट करने के लिए हमको एनर्जी चाहिए इन द टर्म्स ऑफ फोटॉन। one photon one photon is required to eject one electron. Means here when photon will come and hit the electron, it will be eject from the surface, right now. To prove this one, we can't able to prove this one by using the wave, correct now. That's why here they treat the light as a particle nature, and successfully they explained it. And finally क्या है ना, इधर one is wave nature हो गया, another one is, sorry, this is wave nature rectilinear propagation also it's an wave nature, okay. And second one is photoelectric effect will be takes place by the help of particle nature, right now. But here de Broglie came, actually what he said, no, according to the de Broglie he given one statement: every matter, moving matter, okay, along with that velocity, when it is moving, there is a wave will be associated, like that he said. How I will say, देखो, सुनो carefully. This is me, this is me. मेरा mass है 60 kg, मेरा mass है 60 kg. I'm running in the track, I'm running in the track with a velocity 10 meter per second. Oh my god, 10 meter per second means 100 meter तो 10 second में खत्म होता है. Hey, that's a great thing, right? I can participate in Olympics also, correct now. Okay, we can manage this one with a 10 meter per second. It's my velocity, okay. According to de Broglie, whenever I'm also a matter now, correct now, whenever a matter which is moving, no, like this, I'm moving in this direction with some velocity, okay, मेरा पास है mass, along with my body there is a wave will be associated. Means where there is a wave which is associated with the moving matter. It is actually declared by the de Broglie. But you can say, like, you can ask like that, yes sir, when we are running, only the person we can able to visualize the person who is running there. We can't able to see the wave which is associated with that person. Why? Do you know why? Why we can't able to see the wave which is associated with this person? I will tell you why. Okay. Yes. देखो इधर, मान लो ये फुटबॉल है, okay. When you kick the football will be start to move in this direction with a velocity v, okay. उसके साथ क्या है, according to de Broglie there is a wave is associated. मान लो फुटबॉल का मास होता है 1 किलो, मास कितना है 1 kg, and it is moving with a velocity मान लो 20 meter per second है, 20 meter per second. Same thing, you just applied this one to the man, which scenario which I took, no, that one, correct. It took first Einstein energy equation, that is E is equal to h nu. Carefully observe guys, here it is very important. E is equal to h nu, correct now. And E का value क्या है according to Einstein? E is equal to mc square, correct now, is equal to either right hand side h nu means it is nothing but c by lambda, okay. इधर एक c से एक c मर गया, remaining thing is mc is equal to h by lambda हो गया. Actually de Broglie hypothesis क्या दिया? I told you that wave is associated with the matter, means wavelength को calculate करना है. Why it is not visible for us when the object is moving? That is what we have to calculate. Correct now? Okay, coming to the next point. Either the ball is moving means it has a mass m. Correct ना? Mass है, उसके पास velocity है. ये दोनों का product क्या बोलते हैं हम? Let me know. What we are going to call for this one? Mass into velocity. I need answer from you guys. What we will say for this one? Mass into velocity. Yes, right. That is momentum P. Correct now? Yes, coming to this point here again, m into c. C is nothing but speed of light. It has a particular direction. We can call this one as velocity now for this position. That's why I will call this m into c as an momentum is equal to h by lambda. ठीक है ना? हमको क्या चाहिए था? लैम्डा चाहिए. टेक लैम्डा लेफ्ट हैंड साइड, h by p हो गया. Correct now? This is what the de Broglie wavelength. From this wavelength, now substitute the values here. Okay, lambda value is equal to h value कितना होता है? 6.64 into 10 to the power of minus 34 joule second. Correct now? Divided by p means it is nothing but mass into velocity. Let us take the scenario this one. Okay, mass कितना था? Mass 1 kg. Here the example which I took. Correct now? 1 kg mass, right, into velocity कितना? 20 meter per second. Correct है ना? 10 है ना? If it is comes to numerator means 10 to the, इसको we can write like this: 6.64 into 10 to the power of minus 34 divided by 20 को I will write 2 into 10. Correct ना? We can write like this. 20 होता है, 10 to the power of plus 1 is there here. If you take to numerator means minus 1 होता है, then it will become 2 ones are 2, 3.3 means 3.3 into 10 to the power of minus 35 हो गया मीटर. करेक्ट ना? देखो इधर वेवलेंथ कितना मिल गया? एक मैटर, here the matter is the nothing but football when it is moving with a velocity 20 meter per second, the wavelength which is associated with is 3.3 into 10 to the power of, ध्यान दो इधर, it is very important. मेरा लैपटॉप, ओके इधर देखो 10 to the power of minus 35 आ रहा है. Correct ना? Minus 35. Just imagine guys, whatever the wavelength which we are studying here, it is almost all about angstrom meter. My here 10 to the power of minus 35 means it is very minute one. We can't measure that. We can't measure that wavelength होता है ना? Wavelength means like this, crust to crust length होता है ना? Here 2 centimeter है means we can easily measure. Correct now? But it is in the ratio of 10 to the power of minus 35. Correct? Just imagine, is it possible to measure it? Is it possible? No, no, I know. It is no. This is what actually he explained. But this theory satisfactorily explained that this is not for the mass. Okay, mass heavy hai to, if it is mass is heavy means we can't able to see the wave. If we are going to take the value of electron mass, okay, put here only electron mass क्या होता है? Lambda is equal to 6.64 into 10 to the power of minus 34 divided by mass of electron. I'm going to take here now electron mass. Okay, electron mass कितना होता है? 9.1 into 10 to the power of minus 31 into velocity है. We can't able to write the velocity here, right, directly. Correct now? That's why we can take, we'll do one thing. We'll further derive few equation. After then we will put there. Then whether we can able to predict the wavelength of electron or not, we'll prove them. Correct now? First in this point you need to know only the thing is de Broglie wavelength क्या है? Wavelength होता है h by p. Okay, this is the thing which you need to know here. Is it clear, right? This point only. Yes, good. Okay, we don't know the velocity. No, that's why we'll do one thing. देखो इधर ये तो एग्जांपल था, कोई प्रॉब्लम नहीं. We'll do one thing. Now we got an idea about the wavelength. That is lambda is equal to h by p, or else lambda is equal to h by m into v. I'm going to call this equation number 1. We don't know the velocity, right? But we know the value of kinetic energies. Correct? Correct ना? Kinetic energy value क्या होता है? Kinetic energy will be equal to half m v square होता है. Correct what I'm saying? Half m v square होता है. Now you, is it possible to solve the equation for velocity here? Check it once. Velocity को solve करने से क्या आता है इधर? Kinetic energy into 2 will become here, divided by m is equal to v square. Okay, v का equation क्या होता है? Under root होता है. If it is comes to left hand side square means it will be under root 2 kinetic energy divided by mass. Is it right? Correct now. Now the velocity equation we got, right? This is what the velocity equation. Substitute this equation in equation number 1. Correct now what I'm saying? Substitute it. Substitute करने के लिए क्या होता है ना? Lambda is equal to h divided by m into v means under root of 2 times the kinetic energy divided by m. Correct now. If you're going to take the m inside, if you're going to take the m inside means it will become m square. Correct now. Then h divided by under root of 2 m square kinetic energy divided by m है. 1m से 1m कैंसिल हो गया. रिमेनिंग थिंग्स क्या है? लैम्डा इज इक्वल टू h अपॉन अंडर रूट ऑफ 2m टाइम्स द काइनेटिक एनर्जी. करेक्ट ना? 2m times the kinetic energy. Okay sir, this is the value what we got. Okay, now is it possible to find out the wavelength? Again, kinetic energy directly we can't able to get the value of kinetic energy, but we know the value of kinetic energy, right? One equation में आया था kinetic energy value will be equal to E times the potential. Correct है ना what I'm saying? E times the potential. Right what I'm saying? Please do respond here. Yes, we can substitute this one also here. By substituting here, lambda value क्या होता है? Lambda is equal to h divided by under root of 2m e into v. This is also one of the values for the lambda. Note down this one. Note down. Note down. Here, why I kept this butterfly? No. Again, this is a butterfly wave. It has a heavy mass. Right now, we can't able to see the wave which is associated with the butterfly. But if you consider any one point of a butterfly mass, right now, that particle is oscillating. Means that from that particle there is a wave which is associated. To explain that one I took here. No worries, we will take care of it. I will explain it. Okay, we'll move. Temperature हो गया क्या? Electron out. We'll write here. Okay, now what we got actually, the value of lambda will be equals to h divided by under root of 2m. First thing is that kinetic energy, and I told you that kinetic energy we can write as an electron volt. Okay, electron volt से replace करने से lambda क्या हो गया? h upon under root of 2m electron volt. Here electron is nothing but charge of that particle. Charge of the particle. Okay, charge of the particle. Guys, from this equation, I'm going to call this equation number one. इधर देखो, energy तो constant होता है एक इलेक्ट्रॉन के लिए, which is moving with some velocity. Okay, then lambda किसके ऊपर डिपेंड होता है बोल दो, let me know. Lambda is depending upon which function? देखो इधर, if the energy is fixed for a particular charge means either h also constant value, correct ना? It is depending upon mass value. Okay, if देखो इधर lambda value is equal to 1 by under root of the mass, correct ना? If I'm going to take कौन सी mass, alpha particle. Alpha particle means charge 2 होता है, mass number 4 होता है. mass कितना है? mass तो 4 है, correct ना? If I'm going to take the proton means p11, correct ना? mass तो इधर 1 है. And if I'm going to take the electron means the electron mass will be around 1 divided by 1038 times the proton होता है, or else we can say atomic mass unit. This is what the electron mass, correct ना? Now let me know guys, for which particle among these three, has an highest wavelength, and for which particle of mass, okay, wavelength is 2 least. मान लो for all these particle kinetic energy तो same ही है, condition भी बता दिया मैंने. Kinetic energy also same for all the particle. Okay, then let me know for which particle among these three, alpha particle, proton, electron, okay, wavelength is ज्यादा है and कम किसको है? Right, for electron क्या है? ज्यादा और कम means जास्ती ना कड़मे ना. जास्ती means if the mass is less, okay, wavelength is more. Now let me know. Here we have 60 kg means 60 kg, okay, wavelength something what is there. Electron, it is around about 10 to the power of minus 31 kg and wavelength. Correct? Now compare, we will compare these two. Okay, 60 kg and as well as the electron का mass, ये दोनों में, if I'm going to take my weight 60 kg means mass is more. Mass is more means wavelength is too least. We can't able to measure it. Correct ना? But either electron का mass in the ratio of 10 to the power of minus 31. Hence, its wavelength is more. We can measure by measuring, guys. I'm going to tell you one point here. From this point onwards, lambda value will be equal to h divided by under root of 2 into mass of electron means 9.1 into 10 to the power of minus 31 into charge कितना होता है 1.6 into 10 to the power of minus 19 coulomb divided by root, sorry, just a minute, divided by V होता है. V means potential. Okay, and moreover here h is also there. H value को substitute करो. Value of h क्या होता है 6.64 into 10 to the power of minus 34. Correct now? So by solving this one, it is under root only V. By solving this one, we will get lambda value will be numerator में 12.22 angstrom होता है under root of V. Potential के साथ equal होता है. Correct ना? Potential, it's an voltage, right? Either by looking this one, guys, here angstrom में है ना answer. Angstrom means it will be around 10 to the power of minus 10 meter. Correct now? This is the value of wavelength which is associated with the electron. Associated with electron. Correct now. That's why we can able to measure the value of wavelength, which is associated with the electron, right? But if you're going to take the value of means mass around 60 kg or 1 kg means the wavelength ratio कितना आता था 10 to the power of minus 35 or 37 आता 37 meter means it is very minute amount of wavelength. We can't able to measure it. Right now, that's why from this experimental evidence, actually de Broglie proved that the wavelength which is the wavelength is associated with the every matter, but we can measure the wavelength with a smaller mass object like electron, right? In coming chapter atoms है ना उधर we are going to find out the what is the energy which is associated with the electron when it is coming from one orbit to second from second orbit to first orbit, and everything will study in a detailed way. No worries. Okay, just know from this point lambda value is equal to 12.22 angstrom divided by potential. Actually this is what theoretically which is given by the de Broglie. de Broglie दिया था, इसको practically prove कौन किया? Division and as well as German. Before that I think it is you note it down now. The same points, there is nothing changes. Okay, just you guys just note on this equation. This is what important equation here. That is the mass is inversely proportional to the wavelength. Okay, matter में wavelength associate होता है. It is actually set by the de Broglie. How it is associated actually? Smaller the mass means we can measurable wavelength available there. If the mass is more means we can't able to measure the wavelength because it is very smaller. Okay, same thing we need to write the lambda value for the temperature. Temperature. कैसे लिखता है temperature के लिए? देखो lambda value we know that is h divided by under root of 2m times the kinetic energy. Correct now? But in gases kinetic energy value, you know that, right? Boltzmann constant value kinetic energy, that is 3 by 2 k times the t. Correct now? Yes, this is the energy which is equal to 3 by 2 times the k means it is again it is not a kinetic energy. We call this one as an Boltzmann constant. Boltzmann constant. Correct now? Here T represents that absolute temperature. Absolute temperature. Now substitute this value in this equation. Lambda को solve करो, substitute करो. Then lambda value will become either h divided by under root of 2m into kinetic energy means 3 by 2 times the kt. 2 से 2 divide हो गया. The remaining is h divided by under root of m. Okay, we'll write 3m kt. This is also on another equation. Okay, guys, equations तो बहुत है, but you need to know how to solve the equation. Correct है ना? Based on this equation also, so many numericals they asked in a previous NEET question. Clear? Guys, if you have any doubt, please note, please drop your doubts in a chat box. ಅರ್ಥ ಆಗಿದೆ ಅಲ್ಲ? And one more point, I told you that rest mass of a photon. Here one equation will become for this to find the rest mass of a photon. That equation, note down m. It will be give m is equal to m naught under root of 1 minus v square upon c square. Okay, this is the equation which gives the value of rest mass of a photon. Note on this one. So, and next, during this collision, I told no metal plate hai. On this metal plate, electron is there. Electron के ऊपर एक फोटोन आकर टकरा देता है, right? It will come and it will be collide with the electron. When electron is collide with the photon, there is nothing will be changed. Momentum means conservation of momentum will be takes place. Means that here the energy, one more point, the mass of electron will not increase extra. I told you, correct na? And during this collision happen hota na, that collision also like a elastic one. Elastic collision में momentum and energy both are conserved. Both are conserved. Okay, I want to ask one question. What is the speed of photon? Speed of photon. What is the speed of photon? Right, right. It is nothing but speed of a electron. Sorry, speed of a light. Right. This is all about theoretical part. This is actually proven by the German and as well as the diversion experiment. No, I will briefly give an idea about it. What is that exactly? Actually, this is not the experimental setup of the diversion as well as the German. क्या क्या था इधर? देखो इधर एक फिलामेंट है, करेक्ट ना? दिस इज अ फिलामेंट विच इज मेड अप ऑफ टंगस्टन, राइट? टंगस्टन, एक्चुअली टंगस्टन के ऊपर एक कोटिंग डालता है, दैट इज बेरियम ऑक्साइड. Barium oxide. Why means here by coating the barium oxide we can able to generate more and more number of electrons with a high speed. Why tungsten? Why tungsten? Means for a given small amount of heat also, if you give a small amount of electricity also, it will eject the electron very rapidly. बहुत तेजी से क्या होता है? हीट होता है. That's why we are taking tungsten as an element. Okay, इधर से electrons are start to eject. Okay, इधर एक कॉलम रखता है, थोड़ा सा ओपन विंडो रख के, इसको हम कहते हैं कैथोड. ओके, उसके exactly before that, after that we are going to keep anode. Anode means it's actually negatively charged plate. We are going to connect this one to the battery also. Why anode means here the ejected electron hota na, randomly in different direction they will be propagate like this, different direction. But anode kya karta hai, it will be attract the electrons towards it. This collimated beam will be start to move inside the anode where we made a hole. Okay, that electron will be start to move on a निकल टारगेट, करेक्ट? निकल टारगेट के ऊपर क्या होता है? इंसिडेंट होता है. when it is incidenting on a nickel target, after then it will be reflected in a different direction, right? this beam को एनालाइज करने के लिए हमारे पास क्या है? एक मोबाइल कोलिमेटर है, कलेक्टर है. okay, which is actually connected to the galvanometer. why galvanometer? by observe, if you either electrons are will be falling. okay, if you move this instrument here means, okay, mover collector, either electrons will become and interact with this screen, correct? That time it will be this movable collector will collect the electrons, correct? If it is collect the electrons means which is connected to the galvanometer. Galvanometer shows the deflection, means current aa raha hai idhar, correct? This is a sensible thing, right? Like that, this galvanometer scale के ऊपर we can move easily, there is no problem. But when we move this one, no, when we move this one, maximum amount of charges or electron beam we obtain at the angle 54 degree. The angle 54 degree. Okay, suppose मान लो इधर 0 डिग्री है, इधर तो around 60 डिग्री है, correct ना? 0 से if you moving this collimator in this direction, at 54 degree, you might be getting a highest value of current. Highest value of current. Okay, and further, if you're going to move towards the 60 degree, again the value of current decreases. From this point, they said that the potential value is highest at the angle 54 degree. मान लो इधर इधर graph में current what we obtain versus potential. If you're going to draw a current means startingly current value gradually increases, but the peak point it is reaching at potential value will be 50 degree. 50 degree में क्या होता है, बहुत ज्यादा होता है potential value. Okay, then after reaching this one, again if you're moving towards the 60 like that, further angle means again the value of current will be decreased. Okay, this is the experimental evidence which is given by the Davison and Germer, and they given a value also for this one. Actually, lambda value of lambda will be equals to 12.22 angstrom divided by under root of potential, right? By this here, if you put the value of lambda 12.22 divided by potential कितना था 54 volt, correct now? On solving, you will get the value, lambda value will be 1.36 angstrom, correct now? The same thing which is obtained by the de Broglie when he calculated the value of lambda. That's why this Davison and Germer experimental evidence, which is exactly matches the de Broglie wavelength, right? I don't know this theory is I know this is a boring thing, but actually this value will exactly matches the de Broglie. Okay. Okay, कोई बात नहीं. This is all about atoms, but not atoms. Dual nature of matter and radiation. Okay. I hope you understood this one, right? Hope it is clear to everyone. If it is clear, means guys will do one problem. Okay. Thank you. Thank you. Thank you. Problem is that the work function of a sodium is सोडियम का वर्क फंक्शन दे दिया है. ओके, सोडियम का वर्क फंक्शन दे दिया है 2.3 इलेक्ट्रॉन वोल्ट. Does the sodium shows the photoelectric effect? Emission takes place. इतना वर्क फंक्शन दे दिया है, but they given a wavelength of light. Okay, ऑरेंज का wavelength of light दे दिया है 6800 एंगस्ट्रॉम वर्क फंक्शन. ओके, सुनो क्या दिया है बताता हूँ मैंने. इधर एक मेटल प्लेट है, मान लो दिस मेटल प्लेट इज मेड अप ऑफ सोडियम Na. ओके, इसका वर्क फंक्शन कितना है? वर्क फंक्शन वैल्यू विल बी 2.3 इलेक्ट्रॉन वोल्ट है. ओके, on this metal plate actually I'm incidenting the orange color light. कौन सी? ऑरेंज कलर वाला. उसका लैम्डा वैल्यू दे गिवन 6800 एंगस्ट्रॉम. 6800 एंगस्ट्रॉम दे दिया है. ओके, ठीक है. ड्यू टू दिस wavelength, the electron which is present on the metal surface, whether it will be come out or not, we need to calculate. Means the photoelectric effect, whether it is taking place or not. This is the question. I hope you guys understood this one. Okay, let me know whether it is photoelectric effect will be takes place or not. Calculate it and let me know. आपको कैलकुलेट करना है. मींस ये वेवलेंथ दे दिया है, कोई प्रॉब्लम नहीं. कि वेवलेंथ के साथ एसोसिएटेड एनर्जी है ना, उसको कैलकुलेट करना पड़ता है. आई विल एक्सप्लेन. देखो इधर एनर्जी विच इज रिक्वायर्ड टू यू. इधर एनर्जी पता हो गया हमको. एनर्जी वैल्यू क्या होता है? एच म्यू बाई सी. करेक्ट ना? राइट व्हाट आई एम सेइंग? sorry it's my mistake. hc by lambda, no energy. H mu is the energy. Yes, correct. H nu means, okay, we'll write h nu is equal to, h nu means c by lambda होता है, c by lambda. h का वैल्यू पता है 6.64 into 10 to the power of minus 34 into c का वैल्यू पता है 3 into 10 to the power of 8 divided by lambda they given 6800 into 10 to the power of minus 10. Correct ना? Now देखो, for a while, what will do, okay, we'll do everything multiplication वगैरह वगैरह. Okay, 6.64 into 3 कितना होता है? 6 into 3 means 18. 6 into 3 again 18 means it will be 19.8 आता है, something more, into 10 to the power of minus 34 plus 18 plus 8 कितना आता है? 34 में 8 होता है 26 होता है, करेक्ट ना? माइनस 26 माइनस 26 इन डिनोमिनेटर क्या है? 6800 है. इधर क्या करता है ना, मैंने इधर एक पॉइंट लगाता हूँ 6.8 को. यू कैन राइट दिस वन गाइस, देखो इधर 6.8 into 1000 into 10 to the power of minus 10. We can write like this. It will be 6800 10 to the power of minus 10 only. This 1000 को we can write as an 10 to the power of 3. By writing that one 6.8 into 10 to the power of minus 7 होता है, करेक्ट ना? Substitute this value here. 6.8 into 10 to the power of minus 7. Right? Take this term to numerator. मान लो ये 19.8 है ना, इसको हम I will write this one, just a minute. Calculation purpose, just for the purpose of calculation, I will write this one 20 divided by 6.8 को 7 लिख दूंगा मैं, करेक्ट ना? into 10 to the power of minus 26. If it is comes to numerator means 10 to the power of plus 7 होता है, right? 7 कितना होता है ये? 7 3s are 21 means it will be 2 point less होता है, across the 2.8 I think. कितना होता है देखो एक बार, 2.8 होता है क्या? नहीं, नहीं तो कैलकुलेट करो एक बार. 7 1s are 7 3s are 21 है, 7 2s are 14, remaining thing is 6. Okay ना? 60 6.8. Hey, no, it will be come across around 2 point, this one only, so not 2.1. 2 होता है क्या? exact answer. I will do the calculation, no worries. Okay, कितना है? 20 divided by 7, 2.8. Yes, right. I'm right. Hey, क्या हो रहा है इधर? अरे यार, just a minute. Just stay with me for 2 seconds. Dancing हो रहा है इधर. Okay, this is will become 2.8 into 10 to the power of, ये कितना होता है? ये दोनों मल्टीप्लाई करने से 26 से 7 इट विल बिकम minus 19 होता है. ये क्या है? एनर्जी मिल गया हमको, एनर्जी मिल गया. इट इज इन द फॉर्म ऑफ कूल, जौल में है. बट हियर वर्क फंक्शन वैल्यू दे गिवन इन इलेक्ट्रॉन वोल्ट. इलेक्ट्रॉन वोल्ट मींस you need to convert this joule to electron volt. Means energy value will become now 2.8 divided by 8 into 10 to the power of minus 19 divided by 1.6 into 10 to the power of minus 19 होता है. इसको इलेक्ट्रॉन वोल्ट को कन्वर्ट करने से डिवाइड करना है ना, then 19 कैंसिल होता है. Now what is the ratio of 28 by 16? 28 divided by 16, right? इसका वैल्यू आता है, ये वैल्यू अराउंड 1.7 इलेक्ट्रॉन वोल्ट. मींस दिस लाइट which is having a wavelength of 6800 angstrom, इसका energy है 1.7 electron volt, which is actually we are providing to this electron. कितना है? 1.7 electron volt है. Okay, work function था 2.3 electron volt. Now let me know, guys. Wait. Now the photoelectric effect will be takes place here. Yes, that is right. Means here no photoelectric effect. Clear enough? Right. But don't forget, guys, either if you got the answer energy means if you write this one means it's wrong. Right? You need to convert this one for electron volt. Keep in your mind. Okay, this is all about today's class, guys. Okay, power is also not there. I don't know how when it will be khatam hota session. I need to stop the stream. That's why I'm going to stop the class here itself. Before stopping that, I would like to give two homeworks. Take screenshot of this one. Okay, or else I will send you this one in a group. Okay, try to solve this one. In tomorrow class, we are going to solve this one in a class itself, regular class. And I'm going to bring few good JEE mains question and as well as NEET question in a tomorrow session. Okay. Thank you for attending the class. This is a homework question. Okay. Note on this one. And if you don't have any doubt means we can leave the session also. Okay, thank you all. Bye-bye. I will send this one in a class group. Collect the questions from there.